Hello, my name is Ramasu, and welcome to my presentation on question 1 from the 2008 GCSE Science Double Award, Paper 2. The question says, a helmet of mass 500 grams falls from a helicopter. After falling for 5 seconds, the helmet reaches a uniform speed of 50 meters per second. A says, I describe the motion of the helmet during the first 5 seconds. Okay, so the helmet is dropped from a helicopter. Then it falls for 5 seconds, and then it reaches a uniform speed of 50 meters per second. So the first thing that happens when the helmet is dropped is that the speed of the helmet increases, right? Or you could say that the helmet accelerates. At a rate of 10 meters per second squared. Then the second point is that as the speed of the helmet increases, air resistance also increases. And which leads to a decrease in acceleration. Then the other point is that acceleration decreases until it becomes 0. And then the helmet falls with a constant speed. So what happens here is that when the helmet is first dropped, it accelerates at a rate of 10 meters per second squared. But as the speed of the helmet increases, air resistance also increases. It is kind of like how if you've ever been in a car, or in the back of a pickup truck, a truck like this. Now this is a very bad diagram. Let me redraw that. Maybe a Hilux or whatever, right? And you are, and let's say that you're standing here. You're standing in the back of the truck. If it moves, at a very low speed, the air you feel pushing against you isn't very strong. But as the speed of the car increases, the air you feel pushing against you becomes even stronger, right? So when something moves at a low speed, the air resistance against the object is low. But as the speed increases, the air resistance against that object increases as well. So this air resistance decreases your acceleration, right? So it decreases your acceleration. The same thing happens here. When the helmet is first dropped, it accelerates at a rate of 10 meters per second squared. But as the speed of the helmet increases, air resistance against the helmet also increases. And this air resistance decreases the acceleration of the helmet. And then the acceleration decreases until it becomes zero. There's absolutely no acceleration. And when there's no acceleration, it means that the helmet is falling with a constant speed. Right? When there's no acceleration, then your speed is constant. Okay, let's move on to part B1. It says calculate the weight of the helmet. Now weight is given as mass, which is m, times gravitational pull. Or just G. So weight is equal to mg, right? Now our m has to be in kilograms, but it's been given in grams here. But it's been given in grams. So to convert from from grams to kilograms, you divide your grams by 1000. But then to convert from kilograms to grams, you multiply your kilograms by 1000. Right, so we have grams here, and we want to convert them to kilograms. So what we do is that we divide by 1000. So that's 500 divided by 1000 times G. G is given as 10 newtons per kilogram. So times 10, right? Now this is 0.5 times 10. So this gives you 5 newtons. So the weight of the helmet is 5 newtons. Alright? Then part 2 says what is the value of air resistance when the helmet falls with a uniform speed? Well, like I said here, that when acceleration is 0, then an object moves with a constant speed. When air resistance is 0, then the object moves with when acceleration is 0, an object moves with a constant speed. Now when there's 0 acceleration, because the helmet is falling, right? It is falling, being pulled down by gravity. So the force acting on the helmet, so the force acting downwards on the helmet is equal to its weight, right? So then the air resistance acts upwards because it is opposing the motion of the helmet. So then because there's 0 acceleration, it means that the weight and the air resistance are equal. So the value of air resistance is also 5 newtons. Now, to further explain this, we have the equation F equals ma, right? Where a is the acceleration, m is mass, and F is the resultant force. Right? F is the resultant force. Now at first we have no we have no air resistance, right? So then the only force acting on the helmet is just its weight, right? So then our F here is equal to W equals M, right? Our F becomes just W. This is when the helmet begins falling, but as time goes on, and the air resistance increases, then we have the helmet here, then we have its weight, and then we have air resistance, right? Let's call it AR, and then we have air resistance, which means that the resultant force is the difference between weight and air resistance. So then this gives you mass times acceleration. And as the speed of the helmet increases, air resistance also increases, right? It increases up to a point where it now becomes equal. It now becomes equal to the weight. The air resistance becomes equal to weight. So then your W minus your weight minus your air resistance becomes 0. So then you have 0 is equal to MA. Because we know that the mass is 500 grams, the mass can't be 0. So then this means that our acceleration is 0. Okay. So part C says which term is given to this uniform speed. This uniform speed is called a terminal velocity. Terminal velocity. And part D says on figure 1.1, sketch a graph of velocity against time for the motion of the helmet. Well, at first the helmet accelerates, but then its acceleration decreases, right? Its acceleration decreases, and then at 5 seconds it travels at a constant speed. At 5 seconds it travels at a constant speed. So then your graph is supposed to be like that. Let me redraw this again. Well, this is what your graph is supposed to be like. The first part is not supposed to be a straight line. This part here is not supposed to be a straight line. So don't draw a graph like this here, because this is wrong. This line here is wrong because it says that the acceleration was constant, but the acceleration was high at the start, and then it decreased, and then it became 0 at 5 seconds, right? So then your graph is supposed to show that the acceleration was high at first, but then it decreases, and then it becomes 0 at 5 seconds. Okay, so that's the end of the video. My name is Ramasu. You can find me on Facebook, or you can follow my page, BGCSE tutorial videos. If you need more videos, or if you need help, you can find me either at Ramasu or at BGCSE tutorial videos. Thank you for watching, and see you on the next video.